Now, this question 7 from winter 2021, question paper 1-1, it's quite a tricky question. It is about the enthalpy change of neutralization of a strong acid and strong alkali. Okay, strong, strong. Now, they give you two different experiments. This experiment 1, I'll just label it as 1. Okay, this 2, so that it's easier for me to explain later. Now, both cases, they are using the same type of base, sodium hydroxide, okay, and also acid, which is HCl. Now, this strong acid, strong base neutralization, delta H is around negative 57 kilojoule per mole. Now, according to the definition, this per mole of water for enthalpy change of neutralization, if you cannot remember, please go back and look at the list of definitions for different enthalpy changes. So before I start the calculation, let's look at what type of formula we will need for this question. There are two formula. The first one will be Q equals to MC delta T. Now, in this case, we are given the volume of the solution. We are not given the mass, but we always assume that 1 centimeter cube, okay, is 1 gram, right? So we are going to use the volume for M. C is specific capacity. It will be the same for both cases because we use the same type of solution. Delta T will be the temperature rise. So they gave us in case number 1, they want us to find the delta T in case number 2. Right, second formula will be the delta H. Delta H is found by using Q divided by the number of mole of water in this question. Now, in this case, enthalpy change of neutralization is exothermic, so we put a negative in front of this formula. Now, if endothermic reaction, then you put positive, right? Okay, now, in this question, I also need the equation for reaction between sodium hydroxide and HCl. So it's 1-to-1 ratio in this stoichiometry because, okay, 1 mole of salt is formed and then 1 mole of water is formed. So you can see the ratio is 1-to-1 to 1-to-1, right? So everything is 1. So if you can find the number of mole of sodium hydroxide reacted with number of mole of hydrochloric acid, you'll be able to find the number of mole of water to be used in this formula number 2. Right, now since both of them they are using the same type of base and also acid, so they should have the same delta H. Okay, standard enthalpy change will be the same for same type of chemicals, right? Okay, now so for case number 1, I'm going to find the Q. Q will be M. Okay, M will be total volume, 25 plus 25. So which is 50. Times C, I'm going to leave C as C because later we can cancel out uh, in the formula. Okay, because they will be the same for both cases. Delta T here will be 12 degrees Celsius. I know in this one we should use Kelvin, but we are talking about the change in temperature, right? So the change in temperature, we don't have to convert the unit. Okay, they'll be the same. So I'm going to just leave it like this. So in this case, my Q will be 50 multiplied by 12. Okay, 600. Okay, joule. Sorry, C times C, right? Okay, now second equation. Okay, second case, second experiment. Use the same method, right? But this time you see they use different volumes of two solutions. So the Q here will be 50 plus 50, which is 100, okay, times C times delta T. Delta T is not even given. We are supposed to find the delta T. So in this case will be 100 times C times delta T. Right, so how do we find the delta T? I told you, right? Both experiments, they are using the same strong acid and strong alkali. So their delta H will be the same. So 600 C here, okay? The Q for experiment 1 divide by N, the number of mole of water, okay, will be the number of mole of sodium hydroxide or hydrochloric acid because of the ratio 1 to 1 to 1 to 1, right? So to find the number of mole, I'll use the okay, NaOH is actually the same as NHCl, which is the same as NH2O in this case. So will be 25 times 2 divided by 1000. So be 50 divided by 1000, that is 0.05. Okay, so this is my delta H in experiment 1. Should be the same as delta H in experiment 2. So in experiment 2, 100 C times delta T divided by the number of mole of the water in second experiment. Also the same thing. So this will be 50 times 2 divided by 1000. That would be 0.1. Okay, so you see now why didn't I put in the C, because I can cancel them like this. Okay, so if you rearrange to find delta T in the second experiment, it would be 600 times 0.1 divided by 0.05. Okay, you realize that you will get 12. So the increase in temperature in the second experiment is also 12. So the answer is B.